All right, in section 2.1, we will start with a compounding interest formula to find future values. So here in the room that I gave you, let's go ahead and write down the formula for compounding interest or the accumulated amount. Let me go ahead and write down as A. A equals, an accumulated amount equals principal times 1 plus rate divided by n raised to the n times t power. Okay, hold on, let me go ahead and write this as n times t power. You may have seen this in math 161. Okay, A stands for the accumulated amount, the future value. P stands for the initial value, is the principal. This is the initial amount, or I'll say initial value. R is the annual percentage rate, APR, and N is the number of compounding periods per year. And T stands for the number of years. Okay, so first page, we're just using this formula, but I'll show you how to identify what N is and how to use this formula to find the future value of an investment, okay? All right, let's take a look at the problem. Luis invests $5,000 in an account that earns interest at an annual rate of 3.25%. Find the future value of Luis's account after 5 years if interest is compounded A, annually, B, quarterly, C, monthly, and D, daily. Okay, for annual, we can just use exponential growth function, but I'll go ahead and use this formula right here, okay, so that you can see the pattern in all the other parts. So the amount that you will have after 5 years will be equal to, I have to multiply the principal, how much money is Luis investing in the beginning, that will be $5,000, times 1 plus the rate is given as 3.25%. So write down 0.0325. Convert it into decimal by dividing that number by 100. And I'm dividing by 1. Now, if it's annual, then, number of compounding period per year is just 1 because we do it annually. We're looking at 1 year. So the denominator, n, is just going to be 1. And the exponent, the power, will be n times t. Well, n is 1 and t is 5. So I will get the amount of money that Luis will have after 1 year if the interest is compounded annually, okay? I'll go ahead and set all of these up, and I will go ahead and go to the calculator and get all these answers at the same time, okay? But let me go ahead and set up the quarterly problem, okay? The quarterly. The accumulated amount, the future value, will be equal to $5,000 times 1 plus 0.0325, but for quarters. How many quarters do we have in a year? 4. So n is 4. And the exponent, the power, is going to be how many quarters do we have in a 5-year period. So we have 4 times 5, 20 compounding period in that 5-year period. So that will be the answer. I'm going to have to just get to the calculator when I'm done setting up everything. All right, let's go down here and do monthly, okay? The future value is going to be $5,000 times 1 plus 0.0325. But how many months do we have in a year? 12. And how many months do we have in a 5-year period? 12 times 5, so the exponent is going to be 60. So if we do that, we will get the answer. All right, let me set up the last one and I'll open up a calculator, okay? For daily, how many days do we have in a year? we're going to have to use 365 for this problem. $5,000 times 1 plus 0.0325 divided by the number of compounding period, if it's compounding daily, is 365. And how many days do we have in a 5-year period? 365 times 5 will be the exponent. Okay, so all right, I wrote down everything. Now it's time for us to open up a scientific calculator to find all these answers. Okay, all right, let me open up maybe this browser. Okay, I'll go to Desmos Scientific Calculator. Close up that. All right. And I'll go ahead and type in the first one, which is 5,000 times 1 plus 0.0325 divided by 1. Oh, I should put these in a parenthesis. I apologize. Let me put these in a parenthesis. And I'll raise this to the 1 times 5th power. The exponent has to be in a parenthesis too, looks like. So take a look at what I entered. So the answer for the annual part is going to be $5,867.06. Okay, so we got the first answer. I'm going to go ahead and copy this, go to the next line, and I'll change the compounding period to 4 for quarterly. Change that one to 4 there too. So it's going to be slightly more, okay? That time is going to be $5,878.38. All right, let's go find monthly this time. So I'll copy the same thing, but this time I'm dividing that APR by 12, and I say that there are 12 times 5 months if it's for the number of compounding periods. So that will be $5,880.95. I'm just rounding to the nearest cents. All right, last one. What if it's compounding daily? The most frequent out of these 4. 365. Change it to 365. All right, it's going to be the biggest. $5,882 and I'll go ahead and round that up to 20 cents. But that is how you can find the answers to these future value problems. And I think the homework will ask you to do compounding continuously. But I do want to talk about how to come up with that formula first. So I will stop this video here and I will come back and show you how to do compounding continuously in the second video.